Inheritance and Substitution. Introduction.
By inheritance, we mean the property that instance of a child class or subclass can access both data and behavior, that is methods, associated with a parent class or superclass. In this chapter, we will discuss the concept of inheritance and substitution.
The intuitive and practical meanings of inheritance. The syntax used to describe inheritance and substitution. Some of the various forms of inheritance. The benefits and the cost of inheritance. An intuitive description of inheritance. Abstract idea of inheritance. The idea of inheritance was motivated by us with a hierarchy of categories. The following diagram exposes the concept of inheritance in real world. Reasons to use inheritance. Basically, there are two major motivations. Inheritance as a means of code reuse. The code is not needed to be rewritten for the child class because a child class inherits behavior from a parent class. The amount of code needed to develop a new idea is greatly reduced. Inheritance as a means of concept reuse. This appears when a child class overrides behavior defined in the parent. Although no code is shared between parent and child, the former and later share the definition of the method. Note that private aspects of the parent are part of the child, but are not accessible within the child class. There are two common views of class hierarchies. All classes are part of a single large class hierarchy. Thus, there is one class that is the original ancestor of all other classes. Example, Smalltalk, Java and Delphi Pascal. Classes are only placed in hierarchies if they have a relationship. Results in a forest of many small hierarchies, but no single ancestor. Example, C++, Objective-C and Apple Object Pascal. Inheritance is both extension and contraction. Since the behavior of a child class is strictly larger than the behavior of the parent, the child is an extension of the parent. Since the child can override behavior to make it fit in a specialized situation, the child is a contraction of the parent. This interplay between inheritance and overriding and extension and contraction is what allows object-oriented systems to take very general tools and specialize them for specific projects. This interplay is ultimately the source of a great deal of the power of object-oriented programming. The is-a rule. Our idealization of inheritance is captured in a simple rule of thumb. Try forming the English sentences and A is a B. If it sounds right to your ear, then A can be made a subclass of B. A dog is a mammal and therefore a dog inheritance from mammal. A car is an engine sounds wrong and therefore inheritance is not natural, but a car has an engine sounds good. Inheritance in various languages. Syntax for the inheritance in various languages. Languages can use a variety of different syntax to indicate inheritance. Class student public student details. It is in C++. In Java, class student extends student details. In C#, class student details. In CLOS, DEF class student of student details. In object Pascal, type student equal to object of student details. In Ruby, class student less than student details. Subclass, subtype and substitution. Private, public and protected. There are now three levels of visibility modifiers. Private, they are accessible only within the class definition, but memory is still found in the child class, it is not accessible. Public, they are accessible anywhere. Protected, they are accessible within the class definition or within the definition of child classes. Note, Java interprets protected to mean accessible within the same package. Example, the car class has some of its own functions like accelerate, change the gear position, apply brake, start or stop engine, etc. These are the functions which a user can access, which means it has been set as public. There can also be some functions which car require like to know the fuel level and gear position status to start the engine, which the car itself handles on its own, so this has been set as private. Substitution. The following observation can be made on substitution. All data areas associated with the parent class must be possessed by instances of the subclass. Instances of the subclass must implement through inheritance at least, if not explicitly overridden, all functionality defined for the parent class. They can also define new functionality, but that is unimportant for the present argument. As the behavior of the parent class is mimicked by instances of the child class, it therefore seems reasonable that a variable declared as a parent should be able to hold a value generated from the child class. Subclass versus subtype. The problem with substitution is that a child class can override a method and make arbitrary changes. It is therefore useful to define two separate concepts. To say that A is a subclass of B merely asserts that A is formed using inheritance. To say that A is a subtype of B asserts that A preserves the meaning of all the operations in B. It is possible to form subclasses that are not subtypes and to form subtypes that are not subclasses. Overriding and virtual methods. Syntax for overriding. Some languages such as C++ require the programmer to indicate in the parent class that overriding is a potential. The below example shows the method overriding. Class student open bracket public void getName method. It can be overridden bracket closed. Other languages such as Object Pascal require a modifier in the child class that overriding has taken place. Type student equal to object of student details. Procedure getName override, that is in bracket overriding has taken place. End. Still other languages C# and Delphi require indications in both parent and child. And some languages such as Smalltalk do not require any indication in either parent class or child class. Interfaces and abstract classes. An interface is similar to a class but does not provide any implementation. A child class must override all methods. A middle ground is an abstract class. Here are some methods are defined and some abstract methods are undefined. A child class must fill in the definition for abstract methods. The below given shows abstract class and getName method is declared as abstract and it must be redefined in the class which is inherited. Abstract class student open bracket abstract public void getName. Child class must redefine bracket closed. An interface is like an abstract class in which all methods are abstract. In C++, an abstract method is called a pure virtual method. Forms of inheritance. Inheritance can be used in a variety of different ways and for different purposes. Many of these types of inheritance are given their own special names. We will explain some of these specialized forms of inheritance. Specialization, specification, construction, generalization or extension, limitation, and variation. Specialization inheritance. At large, the most common form of inheritance is for specialization. A good example is that Java hierarchy of graphical components in the abstract window toolkit. Component, label, button, and text component has two types. One is text area and another one is text field, checkbox, and scroll bar. Each child class overrides a method inherited from the parent class in order to specialize the class in some way. Specification inheritance. If the parent class is abstract, we often say that it is providing a specification for the child class and therefore it is called the specification inheritance, that is a variety of specialization inheritance. For example, Java class shape. Inheritance for construction. If the parent class is used as a source for behavior but the child class has no user relationship with the parent, then we say that the child class is using inheritance for construction. For example, subclassing the idea of a set from an existing list class. Generally, it is not a good idea since it can break the principle of substitutability, but nevertheless sometimes found in practice, more often in dynamically typed languages such as Smalltalk. Inheritance for generalization or extension. If a child class generalizes or extends the parent class by providing more functionality but does not override any method, we call it inheritance for generalization. The child class does not change anything inherited from the parent, it simply adds new features. For example, Java properties inheriting from hash table. Inheritance for limitation. If a child class overrides a method inherited from the parent in a way that makes it unusable, for example, issues an error message, then we call it inheritance for limitation. For example, an existing list data type that allows items to be inserted at either end, or you override methods allowing insertion at one end in order to create a stack. Generally, it is not a good idea since it breaks the idea of substitution, but again it is sometimes found in practice. Inheritance for variance. Two or more classes that seems to be related, but it's not clear who is the parent and who is the child. Better solution is to abstract our common parts to new parent class and use subclassing for specialization. For example, mouse, touchpad and joystick. Summary of forms of inheritance. Specialization. The child class is a special case of the parent class. In other words, the child class is a subtype of the parent class. Specification. Parent class defines behavior that is implemented in the child class but not in the parent class. Construction. The child class makes use of the behavior provided by the parent class, but it is not a subtype of the parent class. Generalization. The child class modifies or overrides some of the methods of the parent class. Extension. Child class adds new functionality to the parent class but does not change any inherited behavior. Limitation. The child class restricts the use of some of the behavior inherited from the parent class. Variance. The child class and parent class are variants of each other and the class-subclass relationship is arbitrary. Combination. The child class inherits features from more than one parent class. This is multiple inheritance and it will be the subject of a later chapter. Benefits of inheritance. The following are some of the benefits of inheritance: software reuse, code sharing, improved reliability, consistency of interface, rapid prototyping, polymorphism, and information hiding. The cost of inheritance. Although the benefits of inheritance in object-oriented programming are great, almost nothing is without cost of one sort or another. For this reason, we must consider the cost of object-oriented programming techniques and in particular the cost of inheritance. Execution speed. It is seldom possible for general-purpose software tools to be as fast as carefully hand-crafted systems. Thus, inherited methods, which must deal with arbitrary subclasses, are often slower than specialized code. Program size. The use of any software library frequently imposes a size penalty not imposed by systems constructed for a specific project. Message passing overhead. It is a fact that message passing is by nature a more costly operation than simple procedure invocation. Program complexity. Although object-oriented programming is often touted as a solution to software complexity, in fact, overuse of inheritance can often simply replace one form of complexity with another. This does not mean you should not use inheritance, but rather than you must understand the benefits and weigh the benefits against the cost. Example. Inheritance is a process of object reusability. The below given program explains the concept of inheritance. There are two classes, one is parent class and another one is child class. The method P1 is declared in the parent class and method C1 is declared in the child class. Child class can inherit the features of parent class through extends keyword. An object has been created for the child class to access both parent and child class methods. For example, a child acquires properties of parents. Class parent open bracket public void p1 open bracket system.out.println parent method bracket closed. Public class child extends parent public void c1 open bracket system.out.println child method bracket closed. Public static void main string arguments open bracket child cobj equal to new child of cobj.c1 of, that is method of child class, cobj.p1 of, that is method of parent class bracket closed. Summary. Chapter summary. Topics we have addressed have included the following: the meaning of inheritance, inheritance in various languages, subclass, subtype and substitution, overriding, interfaces and abstract classes, the various forms of inheritance, the cost and benefits